For our next set of questions, you need to be able to identify the key features. To remind us what those are: the vertex, the axis of symmetry, the max minimum value, the y-intercept, and the x-intercepts of the quadratics given in the following form. So number 10, not allowed to use a graphing calculator. We need to do this strictly with algebra. And our function is 3/2 x squared minus 3x minus 5/2. So let's get to it. First thing to notice is that this function is in standard form. Alright. So we can start in a couple different places, but the best place to start is with our axis of symmetry. Find the axis of symmetry. And we actually proved this in class, that the axis of symmetry is b divided by -2 times a. So in this form, we can find the axis of symmetry by taking our b value and divided by -2 times our a value. So let's get to it. Our b value is -3 divided by -2 times our a value, 3/2. And yep, I'm kind of a jerk not letting you use a calculator, but just kidding. There's a nice little simplification here. We had -2 times 3 divided by 2. Those 2's undo each other, so we're just left with -3 in our denominator. Alright, and in our numerator we still have a -3. This makes 1. Our axis of symmetry is at 1. X equals 1. Wonderful thing, because now that we have our axis of symmetry in standard form, we can find the vertex. To refresh our memory, we know the axis of symmetry passes through the vertex right at that x coordinate. So our vertex is at 1, comma, something. Where did the 1 come from? From our axis of symmetry. Oops, sorry for the mark there. But that's it. So how do we find the y coordinate? Well, we substitute in 1 into our function. F of 1, I'll replace that in a second, is 3/2 times our input, in this case will be 1, minus 3 times 1 minus 5/2. So just a reminder, we started with the axis of symmetry. The x coordinate of the vertex is therefore 1, and now to find the y value, we substitute in this value 1 into the function and do a little math. Alright, following the order of operations, 1 squared is 1 times 3/2 is 3/2. Take away 3 times 1, that's just 3. Take away 5/2. Alright. So you might want to, sorry, I'm out of room here, bring this back up. Kind of do this in any order, since we're allowed to add or subtract in any order, just paying attention to the signs. So I'm going to take care of this -3 in a second, but I notice I have two fractions with the same denominator, so simple enough. 3 take away 5, or 3/2 take away 5/2 is -2/2 minus 3. And in this case we get another simplification. -2 divided by 2 is -1, still minus 3, which works out to be -4. Aha! When we input 1, the output's -4. Why did we input 1? Because that's the x coordinate of the vertex. So now we actually do know the output here is -4. Beautiful thing. Now that we have the entire vertex, we can also tell the max or minimum value. First we need to figure out whether we have a max or a min. Let's look back up at our function and recall that the a value tells us whether we have a max or a min. I love this little goofy diagram because it always reminds me, if a is positive, the parabola opens upwards and our vertex is a minimum. So we have a minimum value of -4. So -4 is our minimum value. Oops, let's put that in a nice color we can see here. -4. And that's it. And we'll verify this in a second on a graph, even though we're not supposed to use a graphing calculator. But for the review, it's good to just check your work that way. Before we do that, let's look at the y-intercepts or the y-intercept, then the x-intercepts. So the y-intercept, one thing to notice for all these functions, you can always find the y-intercept. We will do this all year by substituting in 0, sub 0 in. Okay. So going back to our function, f of 0 is, well, this is a nice thing about standard form. When you sub in 0, you get a lot of nice simplifications. Alright, so 0 squared is 0, times 3 halves, still 0. Negative 3 times 0, still 0. And 0, take away 0, take away 5 halves is negative 5 halves. So our y-intercept is negative 5 halves, or we can write that as 0, negative 5 halves. That's where we'll cross the y-axis. Alright, to find our x-intercepts, multiple options from standard form. You can try to factor this. I'm not going to cross that bridge. I don't like to factor with fractions. We could complete the square, but that's going to require, it looks like, a lot of work because we need a value, an a value of 1, so we're going to have to factor out a 3 halves, and things are going to get really messy. So let's just use our trusty quadratic formula. And to remind ourselves of that, it's the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Alright, our b value is negative 3, so the opposite of negative 3 is positive 3, plus or minus, once again, our b value is negative 3. Negative 3 squared is 9, minus 4 times a. Alright, so I'm going to write this out because I know we had some fractions, times negative 5 halves. Make sure I don't get messy here. All of that divided by 2 times our a value, 3 halves. Alright, so where to begin? Well, I'm going to begin right here because this is just screaming at me. 2 times 3 divided by 2, 2 times 3 halves. Well, those 2's undo each other, and our denominator strictly is 3. That's wonderful. And we have 3 plus or minus, now we need to do a little work in here. Alright, 9 minus 4 times 3 halves. So we can do this multiple ways. I will multiply 4 times 3 halves, which makes 12 halves. So right here, a little bit of side work. 4 times 3 halves is 12 halves, which makes 6. Alright, so these two make 6, and then 6 times negative 5 halves, well, that makes negative 30 halves, which simplifies to negative 15. Alright, so putting that together, 4 times 3 halves times negative 5 halves all makes negative 15. 9 minus that product, negative 15. Oh, that didn't work out so badly after all. I'll clean this up a little bit more. 3 plus or minus 9, take away a negative 15. That makes the square root of 24, all divided by 3. And we want our answers in simplest form. So a little bit more work here. 3 plus or minus, I know that 4 is a factor of 24. Oops, I'm writing 24 again. Should be writing 4 times 6, all divided by 3. And this makes 3 plus or minus square root of 4 is 2. Square root of 6 does not simplify over 3. In these two terms, the only common factor they share is 1, so there's nothing to factor out in this case. So we're done. These are our x-intercepts. 3 plus 2 times the square root of 6, all divided by 3, and 3 minus 2 times the square root of 6, all divided by 3. Those are exact answers. Now, even I don't know what those are approximately, but since I'm not letting you use a calculator in this question, you just have to double check your work, make sure everything seems reasonable, and those would be your x-intercepts. I will just pull up a graphing calculator to check my work now, and I did this all out. Here's our function, 3 halves x squared minus 3x minus 5 halves. Just recalling, remember our vertex was at 1, negative 4. Our y-intercept was 0, negative 5 halves, which has a decimal is negative 2.5, so that checks out. And then here are the zeros. These are approximate. I also used the Desmos calculator to tell me what those were. 3 plus 2 square root of 6 all divided by 3. This really should be an approximation symbol. It's not exactly this, but good enough. Let's see if we kind of use some estimation here. This is 2.63299, and that's why it rounded this up here as 2.63 right there. And then 3 minus 2 square root of 6 divided by 3 is a negative 0.639 or 6329, which that's going to round up to negative 6.33, which is there on the graph. So there you have it. That's how we find the x-intercepts, oops, sorry for that, of our function. Putting it all together, in standard form, find the axis symmetry first, knowing this formula, b divided by 2a. That is your axis symmetry. Substitute that value in. Find the output of the vertex at negative 4. Our minimum value therefore is negative 4. And just to remind ourselves, yep, that's the smallest place of the graph. The graph never goes below that. And then our y-intercept was negative 5 halves, or negative 2.5. And here are our exact zeros.